Alrighty, so in discussion about projectile motion, we've talked about how the horizontal component and the vertical component are independent. We sort of spent a few days talking about that. Let's just look at how this looks sort of from a mathematical standpoint. Some intro stuff here. I would recommend you not write any of this part down. Just listen, right? If you want to jot maybe short notes, brief notes down, you certainly can. So the vertical and horizontal motions behave independently of each other. We've talked about that. That is, despite having a horizontal velocity VH, the projectile has the usual vertical acceleration of gravity. And you might remember the clicker quiz from yesterday, where I sort of fooled you a little bit with the minus 9.8 question, right? So we know that gravity is minus 9.8. VH stays the same at all times. VH, of course, stands for horizontal velocity. In other words, the downward acting force of gravity does not affect the magnitude of the horizontal velocity. The VH stays the same, unless, of course, we're going to account for air resistance. Exactly. Okay, but we're going to more or less assume that air resistance is negligible. Use the vertical velocity VV in all calculations relating to height of rise, time of rise. Anything that has to do with it going up and down, you're going to be using the vertical velocity. Anything having to do with how far it goes sideways, you're going to use the horizontal velocity. The other one. Okay? Since it is only the vertical component of velocity which causes movement in the vertical direction. So keep your vertical and your horizontal separate. Okay? Very segregated. Oh, I guess. Clickers. It says a bullet is fired from a gun and air resistance is negligible. In other words, we're not going to account for it. The muzzle velocity is 120 meters per second. What do you think I mean by muzzle velocity? Yeah, I mean that's the velocity. The speed with which it leaves the rifle. How far away will the bullet land if it takes 2 seconds to hit the ground? So I think it doesn't say so, but I think what that is implying is that it's going to be fired horizontally and it's going to land like that, right? So it takes 2 seconds for it to hit the ground, which would be the same amount of time it would take if it were just dropped, right? The muzzle velocity is 120 meters per second. How far away will the bullet land? You probably don't even need a calculator for this. If anyone in here does need a calculator, I'm a little bit worried. We've got 3 people who've answered.
Yeah, it's like...
How far away will the bullet hit the ground if it's traveling 120 meters per second and it takes 2 seconds to travel? Go ahead, Kaylin and Sean and Alex. Enter your number now. Or are you waiting for the Jeopardy song?
How don't you know? It travels 120 meters in 1 second.
Oh yeah, it's 240 meters, is it not?
1 second to go 120. So what happens?
2 times 120. Thank you, Mike.
He goes 1 more 20.
And he wonders why the other two.
What?
Nothing.
Oh!
Okay, so here we have a rock is thrown off a cliff at an angle of 30 degrees. There's a picture of a guy throwing a rock off a cliff. Hopefully there's no, burrow or something or other animal at the bottom of the cliff, valley. At an angle of 30 degrees and a speed of 10 meters per second. At its peak, what is the vertical acceleration? So here we have our cliff, right? At the peak, right there, what is the vertical acceleration, do you think? Oh, I guess I need to start the question, don't I? Well, could you, right? Well, you don't need to. You just need to say whether it's, right, this is 10 meters per second, and the angle is 30 degrees. So is the vertical acceleration equal to 10 sine 30, right? Is it equal to 10 cos 30? Is it equal to minus 9.8 meters per second squared? Or you need more info on this question? You can't answer it just yet. The answer every time I ask you vertical acceleration is always minus 9.8. Always. I'm going to keep asking that until it gets all right. Okay. Same guy, same cliff, same angle, same launch speed, same everything. What is the horizontal acceleration?
You draw it.
Can I draw it?
I
Sure.
was going to say draw that triangle again later.
At the peak.
Oh, I know this one from yesterday. I know this one. It's horizontal. I finished.
What is the horizontal acceleration?
You guys weren't listening yesterday. You know.
Correct answer?
D.
Did I not click stop? Thought I did.
D.
Correct answer is D, 0. Did I not just say earlier that the horizontal velocity does what? Remains the same throughout the problem, unless, of course, there is air resistance. It is 0. Okay, here's a sample question. There's some stuntman deciding to drive off the edge of the Grand Canyon. Probably not the wisest move. Hoping they've got some sort of, parachute. I think the clicker quiz is over, yes. Yes, I think that might be the end. We'll see. There might be another question at the end. Let's do this one. Should you write down a sample question?
Yes.
Yeah, probably, right? This part you probably should write down, right? So we've got a car with an initial velocity of 24 meters per second, goes over a 45-meter high cliff. I'm just going to draw my cliff like this. Okay.
He shoots himself in the head before he gets off. He's already dead.
What's the question? Can I go to the next slide? Okay, so find the time of fall. How long does it take the car to fall? Can I copy all this? Yeah, I'll just redraw it. Does it matter the time of fall? Does it matter that he's traveling 24 meters per second sideways?
No.
No, it does not. Why not?
Because they're two independent.
Exactly. The vertical component of the velocity is 24. Sorry, the horizontal component, thank you. And what's the initial vertical component?
0.
Big fat 0. And we are only asking for the time of fall. So we're talking about falling, we're talking about the VV, right? So my initial velocity vertically is 0, right? So how am I going to do this? I've got my distance is 45 and I'm solving for t. Exactly. D equals VIT plus 1/2 AT squared. Should I put minus 45 or should I just put 45?
Can you not do the other one? Just like t equals half dt.
You're going to see that, yeah. I prefer to start with this one because I want to insert that 0. But what about my minus 45 question? Should I put minus 45 or does it matter? You know what, let's put 45 and we can always add a negative in after, right? The initial vertical velocity is 0 times whatever t is just 0, right? So that's why I just get that 1/2. Now, what about acceleration? Should it be minus 9.8? Well, it's down, right? So minus 9.8 t squared. So I've got 45. Exactly, Mike. So half of minus 9.8 is minus 4.9 t squared. If I divide both sides by 4.9, I'm going to get t is equal to 45 over minus 4.9. Oh, t squared, right? If I don't have my 45 being negative, I'm going to be trying to take the square root of a negative, and that's not going to work. So yes, I need the d needs to be minus, and it should be because it's displacement, it's straight down, right? So it displaces minus 45. So work that out.
3.03 seconds.
3.03 seconds, Mike? Sounds about right. All right, so time of fall, 3.03 seconds. Tell me, how far from the base of the cliff will the car land? How far away will the car land?
Very good.
Note that the horizontal component VH and the time in the air determines the distance, right? We're asked for the how far from the base of the cliff. This is known as the range what formula would I use? Is there any acceleration here? No, we've already talked about that earlier. The horizontal acceleration is 0, so what formula from kinematics has no acceleration in it? There's only one. E bar equals d over t. You learned it in grade 10, I think. Maybe even grade 9 or 8. Right? Can I use this one? Yes, because the VH remains constant. So it's simply 24 is equal to d over 3.03. I think it's 72 meters. I can do that in my head. Could you, if you were an accident reconstructionist, could you measure the distance, find out where the car landed, measure that distance, and then measure the height of the cliff, and then figure out how fast the car was going when it went off the cliff?
Yeah.
Would that be something that an accident reconstructionist might need to know?
Yeah.
I would think so, right? They want to know how fast is the car going. Did the person try to hit the brakes before they went over the cliff? Or not? Okay? Or was the car pushed over the cliff? Right? If it's just pushed, then is it going to go very far? No. Okay? So that might be something that maybe, you know, what's his name with the glasses might do. You know? CSI, what's his name? You know what I mean, right? Yeah. David Crusoe. What is the velocity at impact? What is the velocity at impact? Noting that the impact velocity has two components. It has a horizontal, which should remain 24, but the vertical would be based on the acceleration, right? How fast is it going vertically when it lands? So, I know my acceleration, minus 9.8. I know my time of fall was 3.03 seconds, and I also know my distance was 45. No, the vertical distance is 45, right?
Oh, yeah.
So what I'm trying to find VF, I guess, really, right? Which one should I use? I've got A, T, and D.
Should be 0.
Which one? Well, the initial, no, it shouldn't be 0. The initial vertical is 0.
Yeah, when it gets grounded.
Oh, immediately prior to impact, yes. I think I could just use VF equals VI plus AT, could I not? Sometimes I make mistakes. And I am without calculator, so. That would be minus 29.7. So how am I going to find this velocity here? Just Pythagoras, right? Just the right triangle? So I would say something like V squared is going to be 24 squared plus 29.7 squared. Does it matter that I don't put a negative in there? No, because I'm going to square it anyways, and it's just a triangle now, really. It doesn't really matter what direction it is. So my V is 29.7 squared plus 24 squared, and take the square root of that, and I get some weird number.
What is the B squared at the bottom of the black? What is that for?
That is the 29.7 is the speed, the horizontal component of the speed when it hits the ground.
Yeah.
If you were to just drop the car off the cliff, it would be going 29.7 straight down, right?
Yeah.
But it's going 29.7 down and 24 sideways at the same time. So what is the overall result? And I've got some weird calculator here.
Oh, yeah.
Is it like 38.2? Yeah? 38.2, and that's meters per second. Would you say that I'm done, or I still need something? Liam, do you think I'm done? Or is there still another part missing? I need the angle. Very good. I tried not to give you the answer by my tone of my voice. Yes, I need the angle, right? Inverse tan, opposite over adjacent, 29.7 over 24. Make sure you're in degrees, those of you in pre-calc. Just you, Mike. 51. 51? Now, how would you describe that 51 degrees? Can you say like south and east and all that sort of stuff? That's not a terrible way to describe it. Usually we would say something like this would be BTH. And no, that is not a 70s rock and roll band. Below the horizon. Or below the horizontal, right? So it's at an angle of 51 degrees below horizontal. BTH. Okay. So I was wrong about the clicker quizzes. David Letterman used to throw Watermans off a city building. He had this fire training tower that he would take things to. He started with watermelons, and then it was like TVs and like just about anything you could find, he would throw off the building because it was funny. I don't know. You'll see. If he throws a watermelon off a 25-meter high building at a speed of 1.5 meters per second, how far from the base of the building will it land? So now, based on these three parts that I just showed you, right? It's almost exactly the same, except it's a watermelon. Okay? Tell me how far from the base of the building will it land. You have to type it in, and you have to round correctly to 1 decimal point.
I just got a new light goal. Live in a tall house. So go shop.
Go. Go ahead, figure that out. Correct answer is 3.4. Who got it right? All right. Let's see what some people said. Yeah, 3.4, 3.4. Liam didn't round very well. He put 3.3. Austin got 3.5. Must have misrounded. 55. Sorry, Adrian. Yeah, no. Okay, so those are the only two there that are... Lucky, why didn't you answer?
I shut my finger off and I was straight through. I got 3.3.
Did you? Okay. Okay, so you have that sheet from yesterday. It has the chimney sweep falling off the roof. You guys can work on that. Tomorrow I will do another series of problems.